Hi there, continuing on in our probability unit. This lesson is on theoretical and experimental probability. So what is the difference between theoretical probability and experimental probability? Theoretical probability is what should happen. You for sure want this written down. Experimental probability is what actually happens after we do the experiment. If a coin is flipped 10 times, theoretically, how many times should it land on heads? Well, we know that if we flip a coin one time, the probability of getting heads one time is 1/2, right? Because it can either get heads or tails, so there's two total outcomes. Heads is one of them. So 1/2, which tells me that 50% of the time, theoretically, I should get heads. So if I flipped it 10 times, then theoretically, we'll write it down here again, the probability then, if I flip it 10 times, theoretically I should get it 5 out of 10 times, which still is 1/2, which is 50%. If the coin landed on heads 7 times, what is the experimental probability of the coin landing on heads? So the probability of heads after my experiment, because I got it 7 times, was 7/10, which is 0.7, which is 70%. Because I flipped it 10 times and I got it and I got heads 7 times. If I spun the spinner 40 times, what is the theoretical probability of landing on a 2? So let's just look, if I spin it 1 time, the probability of landing on a 2 is 1/4, because there's one section of a 2 and then there's 4 total sections, which is 0.25, which is 25%. So if I spin it 40 times, what is the theoretical probability of landing on a 2? It should still be 40%, theoretically. So probability of a 2, if I want it to be equal 25%, I can take my 1/4, because I know the theoretical probability of landing on it just after one spin is 1/4. So I could take 1/4 and I could change it to 40ths. So we want to figure out what can I multiply by to get to 40ths. I know that I can do 4 times 10 and then 1 times 10. And so that would get me to 10/40ths. So because 10/40ths is the same as 1/4, if I simplify that, I get 1/4, but then that's also 25%. So again, theoretically, if I spin the spinner 40 times, it should land on a 2 10 times. Just like theoretically it should land on a 1 10 times, it should land on a 3 10 times, it should land on a 4 10 times. Obviously, we know that it does not happen as it theoretically should. If I landed on a 2 16 times, what is the experimental probability of landing on a 2? So again, we rolled it 40 times, so the probability of landing on a 2 after my experiment, I rolled it 40 times, and I spun the spinners 40 times, and I got a 2 16 times. So that's how that's going to be. And then we're going to simplify that. And I know that 16 and 40 can both be divided by 8. So let's simplify that down to 2/5. 2/5 is the same as 0.4, which is 40%. So theoretically, I should have gotten a 2 25% of the time, but after my experiment, I actually got a 2 40% of the time. So my experimental probability of getting a 2 is higher than my theoretical probability, because I got a 2, I spun a 2 more times than I should have done based on theoretics. Okay, let's look at a couple different situations. If I roll a dice 6 times, theoretically, how many times should I roll a 2? Theoretically, If I roll it 6 times, I should get a 1, a 2, a 3, a 4, a 5, and a 6. So theoretically, I should roll a 2 1 time. If I roll a dice 24 times, theoretically, how many times should I roll each number? Well, I know that 6 times 4 equals 24, which means that I'm going to take this, I'm going to multiply that times 4. So theoretically, I should roll each number 4 times. And because there's 6 sides on the die, 24 divided by 6 also gets me to 4. If the experimental probability of rolling a 5 was 7 24ths, what does that mean? That means that I rolled a 5 7 times out of 24 rolls. It also means that my experimental probability was higher than my theoretical probability because it should have theoretically, remember, it was 4 24ths and I got 7 24ths. Try pausing and do these problems on your own and then come back and check. And then lastly, Netflix is looking at last year's movie streams by genre to determine what genre they should focus on for next year's movies. Last year's streams are shown in the table. What was the probability that a comedy movie was streamed? Is this experimental or theoretical? Because we're using the information from last year, this is experimental. And we know I added them all up and I got 2,000 total streams. And there was 580 comedies. So I simplified that down to 58 200ths and 2900ths, and that was 29%. This year, Netflix expects to have 5,000 streams. How many drama movies should they create? Is this experimental or theoretical? This is theoretical because we're taking the information of our experiment and we're using that for next year. So we're using the information that hasn't happened yet. So theoretically, next year, we should need this many drama movies, whether we really do or not. They're just using the previous information. So based on our experimental data, 450 drama movies out of 2,000. I know that 2,000 times 2.5 equals 5,000 because that's what we're trying to figure out is how many out of 5,000. So then I just did the same on the top and I got 1,125 over 5,000. So that would tell me next year they should make 1,125 drama movies. Alrighty, have a super day.